All right. So the note sheets are going to look a little different just because internet is down. So I went on and wrote these up just so that we had the main descriptions. So vertical stretch and shrink is where we ended yesterday. We said a function has a vertical stretch if a is greater than 1. So if a is greater than 1, it's a vertical stretch. If 0 is less than a is less than 1, it's a vertical shrink. And the amount that it stretches or shrink will be listed. So it's a vertical stretch, we will say it's a vertical stretch by that given amount. If it's a vertical shrink, we'll say it has a vertical shrink by the given amount. So as we look at this first one here, g of x is equal to 2 times the absolute value of x. And again, like with everything, all these here, we need to first identify the parent function. What is the parent function of this here? Absolute value. It's the absolute value function. Which means the general equation for this here is y equals a times the absolute value of x minus h plus k. Do we have a value for k? Do we have something added to the end or subtracted? No, so that means it does not move up or down. Do we have a value for h, moving left or right? No, so there's no left or right movement, but there is a value for a, yes? Is the value of a negative? No, because if it was, then it would be a reflection across the x-axis. Because a is positive, there is no reflection. But because it is 2, it's telling us that there is going to be a vertical stretch or a vertical shrink. And it would indeed be a vertical stretch because the value of a is greater than 1. So for this one here, we would say it's a vertical stretch of 2. Because we do distinguish, or we do note, how much the function is stretching or shrinking by. Since it's 2 times the absolute value of x, since a is 2, we would say it's a vertical stretch of 2. Questions on this here? Let's look at the second one up here. H of x equals 1/2 x squared. What would the parent function be? Quadratic. So we'd have y equals a parentheses x minus h squared plus k. Now we need to describe the transformation, how it's being transformed, how it's being affected from the parent function. Now if we look at h, is there a value for h, movement left or right? No. Is there a value for k, moving it up or down? No. Do we have a value or something in place of a? Yes. We have the 1/2. Is it negative? No. It is not negative, so there is no reflection across the x-axis. But because we do have a value there, it's going to tell us it's either a stretch or a shrink. It's a stretch if it's greater than 1. It's a shrink if it's between 0 and 1. So this here would be what? Vertical shrink, because the value of a is between 0 and 1. 1/2 is between 0 and 1. So it's a vertical shrink. Questions on this here? We good with this so far? Are you ready for the next one? G of x equals 3x. What is the parent function? Linear. Equation of line, x. it might seem a little silly we keep going through all of them, but might as well. Is there a value for k? Is there a movement up or down? No. So there's no movement up or down. We don't have to list it. Is there a number in place of h? Left and right. So we all agree there's no left or right movement, yes? We do have a value for a. It is 3, yes? Is it negative? No, so there is no reflection across the x-axis, but we do have what? A vertical stretch of what? Because a is 3, a is greater than 1, it has to be a vertical stretch of 3. All this is saying for this function here that all the y values are increasing by a factor of 3 from the parent, because it would normally go up 1, it's now going up 3. Because if we were to graph this, this is the normal parent function. Now if we said 3x, we can see it's now increasing faster. We stretched it along the y-axis. Let's say 1/3. 1/3 would be a vertical shrink, yes? So we can see here that it's increasing slower. It's being stretched or compressed along the y-axis. It's a shrink. Questions on any of this here? Let's look at h of x. H of x equals 3/2 x squared. Which parent function does it belong to? Quadratic. Do we have a horizontal translation? Do we have a value for h, moving left or right? Do we have a vertical translation? Is it moving up or down? Nope, no value for k. Do we have a value for a? Yes. Is it negative? No, so there is no reflection across the x-axis. But it is a fraction, yes? So does that mean it's a vertical shrink? What is vertical shrink? Is a vertical shrink if 0 is less than a is less than 1, if a is between 0 and 1. Is 3/2 between 0 and 1. 3/2 is 1.5. 1.5 would indeed be greater than 1. So this here would be a what? Vertical stretch. Just because it's a fraction doesn't necessarily mean it's going to be a vertical shrink. TCH. It would be a vertical stretch of 3/2. Questions on any of this so far? Are you ready for the next one? Last one for this here is c of x equals 0.2 times the absolute value of x. Well, our parent function would be absolute value, absolute. Y equals a times the absolute value of x minus h plus k. Do we have a value of k? Do we have a movement up or down? No. Do we have a movement left or right? Do we have a value for h? No. We do have a value for a. Is it negative? No. So there is no reflection across the x-axis. But the 0.2 is telling me that there's a vertical, because it's going to be a stretch if it's greater than 1. Is it greater than 1? No, so it has to be a shrink of what? 0.2. Okay, stretch and shrink is the number, it's not the sign. The sign is reflection. Questions on stretch and shrink? All right. We ready for the last set of problems? Now, they gave us a graph. The note sheet does have a graph. I just don't have the graph. We have that V-shaped graph. It does have the equation written right there. F of x equals 2 times the absolute value of x plus 1. What is our parent function? Absolute. So it's an absolute value. Y equals a times x minus h plus k. This is our absolute value equation. Now, do we have a value for h? Do we have a movement left or right? We don't have a number added or subtracted inside the absolute value, so there is no movement left or right. Do we have a value for k? Yes, and that value is 1. K is nice because positive is up, negative is down. So having plus 1 tells us it moves up 1. So part of our transformation is up 1. And really, up to this point, that's the only thing we have. Yes? However, is there a value for a? Yes. Is it negative? No, so there is no reflection across the x-axis. But we do have a vertical stretch or a vertical shrink. Is the value of a between 0 and 1? Is 2 between 0 and 1? Well, no. Is it greater than 1? So it has to be a vertical stretch of 2. So the transformation for this one here was up 1 and a vertical stretch of 2. That's it. That's also why each time we went through all of them, because we could have a transformation for each one. I will say this, we will have a vertical stretch or a vertical shrink. You will not have both. Are you ready for the next one? G of x equals 1/4 times x minus 3 squared. What's the parent? It is a quadratic. So looking at this one here, do we have a value for k, movement up or down? No, there's nothing added to the outside or subtracted from the outside of it. Do we have a value of h, our movement left or right? We do. And we're moving 3 units. Now we need to determine, are we moving 3 units to the left or 3 units to the right? To the right. Left and right's the opposite of what we think because it seems negative. We're moving to the right because the general form is x minus h. So our actual value of h is not negative 3 but positive 3. So we're moving right 3. Do we have a value for a? Yes. Is it negative? No, so that means there is no reflection over the x-axis. But the 1/4 is telling me that there's a vertical stretch or shrink. Is 1/4 greater than 1? No, because 1/4 as a decimal is 0.25. It's between 0 and 1, so it's a vertical shrink of 1/4 or 0.25. Both are the same thing. So the description, our transformation for this here, is right 3 and a vertical shrink of 1/4. That's it. Questions on this here? Questions on anything we've done so far? We do have two more. G of x equals negative absolute value of x plus 5 minus 3. What is, it would be absolute value. Do we have a value for k? Yeah, so that's telling it's moving the graph up or down by how far? Down 3, because it's minus 3, so it would indeed be down 3. Up and down is nice because it's exactly what it looks like. Since it's negative, it's moving down, and we're moving down 3. Do we have a value for h? Left and right. How far are we moving? Left 5. Because it looks positive, but it's actually negative because our x minus h, the only way we can go from x minus h to x plus 5 is that the value of h is negative 5. So left 5. Since a is negative, we do have a reflection across the x-axis. Now the number with a is 1, because it's really negative 1 sitting there, yes? Now vertical stretch and shrink, it's a vertical stretch if that number is greater than 1. Well, it's not greater than 1, because a in this case is just 1. And vertical shrink has to be between 0 and 1. Well, it's 1. There is no vertical stretch, there is no vertical shrink. Feels like it should be, especially with the negative. But the negative is not attached to vertical stretch or shrink. The negative is our reflection. Those are two separate transformations. Once we say the reflection over the x-axis, we've taken care of the negative. The number itself is 1. There is no stretch or shrink if a is 1. Questions on this one here? It might be nice to actually see where we have a stretch or shrink and a reflection at the same time. H of x equals negative 0.25x squared plus 4. Parent. Quadratics. Do we have a movement up or down? Up 3, because we have plus 4. So that plus up 3, up 4, yes? Plus 4 tells us we're moving the graph up 4. Do we have a value for h? No, there's no parentheses, so h isn't there, so there is no movement left or right. Do we have a value for a? We do. Is it negative? Yes, so the negative tells me that there is a reflection across the x-axis. That's all the negative tells me. The negative tells me there's a reflection across the x-axis. The 0.25, not negative 0.25, the 0.25 tells me that there is a vertical stretch or a vertical shrink. And it would indeed be a vertical shrink because our number, our value of a, not the negative, just the number is 0.25. 0.25 is between 0 and 1. So it would be a vertical shrink of 0.25. Questions on this here? We kind of see especially how vertical stretch and shrink in reflections, they are two different things at the same spot. The negative tells us reflection. The number tells us stretch or shrink. And especially with this one here, we would not say a vertical shrink of negative 0.25. We already took care of the negative. The negative is told to us, and we're telling it through the reflection, not the stretch or shrink. They're two separate entities. Questions on any of this here? All right. Homework 3 through 5. On problems 3 through 5, 3, 4, and 5, identify the function family. So linear, absolute, quadratic. And then describe the transformation, exactly what we've been doing. 19 through 15 odd. Not 19, 9 through 15 odd. So you're only doing the odd problems. Do not graph. Identify the parent function. Describe the transformation like we've been doing. 19 through 27 odd. Do not graph. Describe the parent function. Name the parent function. Describe the transformation. 28 and 31. Do not graph. Name the parent function. Describe the transformation. That's all you're doing on all of these. Name its parent function. Describe the transformation. Name the parent function. Describe the transformation. That's it. You have the entire rest of the class period to work on this.